Okay, the following is a video over 0.8 notes, which are systems of linear equations. I want to talk about what exactly a system of equations is. And what I'm going to have to do is I'm going to draw a little graph here real quick. And I'm going to call this the x-axis and this the y-axis. And let's say that I have two lines, okay, just two arbitrary lines. Well, the point at which these two lines meet is called the solution to a system of equations, okay? That's what we're concerned with. We'll be giving you two equations, and you want to find where they intersect, okay? So solution to a system of linear equations is the point where, oops, two lines intersect, okay? And so normally you're going to have one solution, okay? Let's say, for example, that you've got two lines that, and I'm going to use a different line up here, but I'm going to say that I've got this line here and this line here, and let's say that these lines are parallel. Okay, so these lines are parallel. Parallel. Okay, and if lines are parallel, meaning they have the same slope, so lines are parallel, they'll have the same slope, then what we want to, these lines are not going to intersect. Okay, so therefore there is no solution here. So if lines are parallel, then there's no solution. Okay, let's take a look at a third case. Okay, so you've got three cases here with systems of equations where you've got, a graph, and you've got, say, one equation, one line that's, say, going like this. And let's say that you have another line that is directly on top of that other line, okay? So you have two lines that are the same, okay? And if you have two lines that are the same, then they have an infinite number of intersection points. They're always intersecting, okay? So you have an infinite number of solutions. So you have infinite solutions. Okay, you've got three cases here. Okay, and so you've got two different lines that intersect. You've got two different lines that don't intersect, and then you've got two of the same line, and they always intersect. Okay, so let's take a look, and let's do part A. Let's graph these two lines, and let's see. Find the solution and then determine if you have no solution, one solution, or infinitely many solutions. So what I'm going to do is I'm going to come up here, I'm going to start at 3. So this is if I have this equation here, y equals negative x plus 3, I know my slope is equal to negative 1, and my y-intercept is equal to 3. Okay, so I'm going to come up here to 3, and I have a slope of negative 1, so I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And I'm going to connect these points with a line. Let me get a better line than that. Okay, so I'm going to graph these lines. Okay, and then let me extend this one out just a little bit. Okay, and so let me graph this other one. This line has a slope of 2 and a y-intercept of negative 3. Okay, so I'm going to go down to negative 3. It's my first point that I plot. I'm going to go up 2 to the right 1. Okay, up 2 to the right 1. All right, and I'm going to connect those points, and what we see here is we have a point of intersection. Okay, and that point of intersection, well, we're just going to go ahead and call that my happy place. And that is the point of 2, 1. Okay, that's the solution to this system of equations. And because I have one intersection point, I have one solution. okay? And my one solution is the solution, the point 2, comma 1, okay? All right, let's take a look at another one. And both of these are, you know, you can graph them in this form. I'm going to go ahead and put them into slope-intercept form real quick. I'm going to solve each of these for y. So in part B, I'm going to start with the equation y minus 2x is equal to 6. I'm going to add 2x to both sides. And so I get the equation y is equal to 2x plus 6, okay? And so I know that in this equation, I've got a y-intercept, a slope of 2 and a y-intercept of 6, okay? So I'm just going to graph that real quick. I have 6, and then I go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, all right? And I'm going to graph these, graph that line. Okay, extend this out just a little bit. And let me do the other equation. Okay, now the other equation was 3y minus 6x is equal to 9. Okay, I'm going to add 6x to both sides. And so then I get 3y is equal to 6x plus 9. I'm going to divide by 3, and divide by 3. Got to divide everything by 3, folks. All right, so then I get y is equal to 2x plus 3. Huh, look, guys, I've got the same slope here. That means that these lines are going to be parallel, okay? And so if I plot my point here at 2, no, I'm sorry, not y-intercept of 3. So let me plot my y-intercept of 3. All right, and I've got a slope of 2, so I'm going to go up 2 over 1, up 2 over 1, down 2 to the left 1, down 2 to the left 1. Guys, these lines are not going to intersect. All right, they're parallel. Okay, so there's no solution. I'm going to write that. I've got no solution here. Okay, and that's because the lines are parallel. Okay? All right, let's take a look at the next example. The next example says use substitution to solve the system of equations. Okay, so you can always do graphing, or you can do substitution. I like substitution, but here's what I know about these two equations. Okay, I've got the equation y equals negative 4x. Okay, that's what y is equal to. Now I'm going to take that entire thing here, and I'm going to substitute that in for y in this equation. So watch what I do here. Okay, I've got the equation 2 times y, but you know what? I don't want to write y. I want to write what y is equal to, and that's going to be negative 4x. So I'm going to write in here negative 4x, okay? And let me rewrite this in red. Okay, and then we do plus 3x is equal to 8. Okay, at this point, what we can do now is we can solve this equation for x. Okay, I can take 2 times negative 4, so 2 times negative 4 is negative 8x, plus 3x is equal to 8, okay? And so if I take negative 8x plus 3x, I can combine those, and I'm going to get negative 5x is equal to 8, all right? I'm going to divide everything by negative 5 and divide everything by negative 5. So then I get an x value of negative 8/5. Okay, and so that's the x value on my graph that is where these two equations intersect. Okay, now what I need to do is I need to take this value and I'm going to substitute it back in for x up here to solve for y. Okay, so I know this. I know that y is equal to negative 4x, but I don't want to write x. I'm going to write what x is equal to. So watch this. I'm going to do negative 4 over 1 times negative 8 over 5. Okay, and so I get this. I get y is equal to negative 4 times negative 8. That's going to give me positive 32 over 5. Okay, and that's my y value. So my answer, my solution that I have to write as an ordered pair is the point negative 8/5, comma, 32/5. Now, guys, the reason why I had to do this one and the reason why we're getting fractions is because not every linear equation is going to give you a nice, neat numbers that you can actually recognize on a graph. Okay, it's sometimes doing it algebraically will actually give you the correct answer in the easiest way possible. Okay, so that's substitution, where I take one equation and substitute it into the other equation. Okay, then we also have this method of elimination. Okay, and this example is a little bit different, but my goal is to do is to eliminate one of the variables. Okay, and so what I notice here is that I have a 3x, a 4x, a 5y, and a 2y. Okay, there's nothing really in common with either of these numbers, but let's just go ahead and get rid of the x. Okay, now what I'm going to do is I'm going to multiply this top one by -4. Okay, I'm going to multiply this entire equation by -4, and then I'm going to multiply this entire equation down here by 3. Okay, notice that I'm multiplying the top equation by the bottom coefficient, and I'm multiplying the bottom equation by the top coefficient. One of them has to be negative. Okay, so what ends up happening is I get this. All right, I'm going to take -4 times 3x, which gives me -12x. I'm going to take -4 times 5y, which gives me -20y. -4 times 7, which is going to give me -28. All right. If I distribute the 3, I get 3 times 4x is +12x. This is what I'm looking for, folks. I want to get this. I want to get one of these where one of them is the opposite of the other. Okay, then I've got 3 times 2y, which ends up giving me +6y. And then I've got 3 times 0, which is just 0. Okay, so now what I'm going to do is I'm going to add these two equations together. Okay, and the -12x plus 12x, that adds to 0. That gets eliminated. Hence, the name elimination. Okay, so now I'm going to take -20y plus 6y, and that's going to give me -14y. And that's going to equal -28. Okay, now I can solve for y. Okay, y is the only variable that I have left. I'm going to divide by -14 on both sides. And this ends up giving me +2. So y is equal to +2. All right. So now what I have to do is I'm going to take this, I'm going to substitute it back in. I'm going to use my bottom equation because my numbers are smaller. And I'm going to plug in this value in for 2 in for y, and I'm going to solve for x. So I get 4x plus 2 times y. Well, y is equal to 2. So I'm going to plug in 2 here and set that equal to 0. So then I get 4x plus 4 is equal to 0. And guys, I can solve this for x now, okay? So I'm going to subtract 4 from both sides, subtract 4, and I get 4x is equal to -4, all right? So now I'm going to divide both sides by 4 and by 4, and so I get that x is equal to -1, okay? So I have an x value, I have a y value. I can write my solution as an ordered pair. Okay, I can write this as -1, 2, and that's my answer. Okay, the trick here is to try and manipulate these equations so that you get the same number. You got to do that by multiplication. Usually what I do is if I pick one, we could have done y first if we wanted to. I chose to do x. Okay, so I multiply each of the equations by the opposite one. One of them has to be negative. Okay, so that's all I got. You know, this is really a fun video, guys. I hope you enjoyed it because I really had a good time making it.